shows that momentum is given by, so we will start by writing E equals CB, and we need here H and lambda, so we can make E equals HF or HC over lambda, hence HC over lambda equals CB. We can eliminate C from both sides and we get the formula wanted. Use the previous expression to show that momentum is by this value for a red light. We know that visible light extends from 400 nanometer to 700 nanometer. 400 is for violet and 700 is for red. So we'll use 700 and we will substitute as usual H to be this value over lambda here should be converted to meter. Okay, and we will get the answer. Let me pick the calculator. Okay, it's 947, almost 9.5 times 10 to minus 28, and certainly Newton second. A beam of red light of intensity 160 watt meter minus 2 is incident normally on plane mirror shown in figure. The momentum of each photon in beam is, so it's the same value that we have just obtained for a red light beam. Okay, all of the light is reflected by mirror in opposite direction to its original path. The cross-sectional area is 2.5 times 10 to minus 8 meter squared. Okay. Show that number of photons incident on mirror per unit time is this value. Okay, what is number of photons per unit time? It's N over T. And how can we get N over T? We know that power is number of photons times energy of photon over T. This gives the total energy, and total energy divided by time is equal to power. Okay, so do we have power value? We have intensity value. So as we know that intensity equals power over area, we can say that intensity times area equals N over T that we need as a subject times E. I will put it here to make N over T the subject. So we can substitute 160 for intensity. Okay, and this 2.5 value for cross-section, and energy of photon is, we can say, C times B. So B that we calculated a couple of moments ago. Remember the power is 10 to minus 28. Okay, so answer will be 1.41 times 10 to power 15, and certainly second minus 1 in here has no unit. Someone may say we can state it as photons per second, but photons is an intuitive word for number of photons, certainly, so we mostly don't include in units. Okay, now pressure is wanted. B here, B is B for pressure, not B for power. Don't confuse it. Equals force over area. So we need force, and we know force from Newton's second law is delta B over delta T. Okay. We need here delta B. You may notice that the question says the light is reflected by mirror. When beam is reflected, photons has momentum that is negative in sign to the momentum where photon was falling on the mirror. Okay, so momentum of photon when it is reflected is minus b. Delta b equal momentum after, which is minus b, minus momentum of error, which is positive b. So it is minus b, which equal minus 2b. We want here the magnitude, so we will take 2 times this value as delta b. So 2 times over the time. I want to add here that this is the force exerted by only one photon. If we want the total force to find the pressure, we have to multiply by number of photons. So n delta B over delta T is force exerted by all photons, which is the force exerted by the beam on mirror. Again, n over delta T is number of photons per time that we calculated here. Okay, so we can write this as delta B over 1 times n over delta T 1.41 times 10 to 15. Okay. This is the force. We can calculate it first. 2.68, and certainly Newton. We want the pressure, not the force. We have to divide this value by area. So we get the final answer as 1.07 times 10 to minus 6 Pascal. The beam of red light is now replaced by blue light of same intensity. Red to blue means a decrease in lambda. Okay, so frequency increases or lambda decreases, and it's of same intensity. Again, we know that intensity is related to number of photons and energy of photon. Okay, so as frequency increases, energy decreases, and hence number of photons increases. Okay. State and explain why pressure on mirror by beam is less than, same, or greater than pressure of red light beam. Okay, we can return back to the formula of pressure. We can write here that pressure equals N over delta T 2B we have area constant, and we can say that the pressure will be affected by number of photon, and B as it equals H over lambda, so it will be affected by lambda. Lambda decreases, B here, B once again is the momentum, B increases. Okay, so we can write here that B increases, and as energy decreases, N increases. So we can say that B pressure, which depends on N and B, okay, have an increase in N, but a sorry, from the beginning, frequency increases, lambda decreases means energy increases and N decreases. Okay, so we have here N decreases, and B increases, so we expect B to be the same, because an increase in B will cancel the decrease in N, and we will have pressure the same.